Today we're going to learn about arc and angle relationships. This is section 11.5. The first thing that I want you to do is to write down these formulas on your guided notes. If your angle vertex is on the center of your circle, then the measure of the angles equal to the measure of the intercepted arc. If, on the other hand, your vertex is on the circle itself, then the measure of the angle is equal to half the measure of the intercepted arc. If the vertex of your angle is outside the circle, then the measure of the angle is equal to half the difference between the big arc and the small arc. That will make some more sense once we do a few examples. If the vertex of your angle is inside the circle, not on the center, then the measure of the angle is equal to half the sum of the two arcs. And again, that formula will make more sense once we do a few examples. So if you're not done writing this, pause your video and finish writing it now. Next, I'm going to want you to label each of the examples as being on the center, on the circle, outside of the circle, or inside the circle. So pause your video and label all of your examples with one of those four words. Now we're going to check your answers. You can see that number 1 is on the circle, number 2 is outside, 3 is in, 4 is on, 5 is on, 6 is out, 7 is in, 8 is on, 9 is on, 10 is in, 11 is on, 12 is on. It's really important to be able to identify where the vertex is because it's going to dictate what formula you use. Let's try some problems where the vertex is on the center of the circle. We're going to first look at example number 4, and you can see this is the easiest kind. I have my vertex here on the center, so the measure of my angle must be equal to the measure of the intercepted arc, and in this case x is just equal to 95 degrees. Next, I want you guys to try this one. You're going to have to set up an equation and solve for x. Pause your video, and when you resume, I will display the answer. Now, you can see that I set up my equation so that the angle is equal to the arc. And then I just solved by subtracting 8 from both sides. And then I subtracted 6x from both sides. And then finally I divided by 3 to get that x is equal to 8. To find the measure of the angle and the measure of the arc, I went and substituted back in the 8. And I found that the measure of my angle was 80 degrees. I could have also substituted it into the formula for the arc and gotten 80 degrees as well. If I got something different, it would mean that I did something wrong in my algebra. So they should both be 80. Now we're going to try some problems where the vertex is on the circle. If you look at problem number 1, this is the case. My vertex here is on the circle. And I'm going to use the formula. The measure of the angle is equal to half the measure of the intercepted arc. Now, I can see that my angle is x, and it's going to be equal to 1/2 the measure of the intercepted arc, which is 220. And I'm just going to substitute into that formula and solve. X must be 110. Now, let's take a look at this one. This is a little different because you'll notice that this is 54 degrees here, but the arc I'm looking for is not the intercepted arc. In order to find x, we're first going to have to use this angle. And in case you didn't notice, this is problem number 5 from your guided notes. So this angle is supplementary to the 54-degree angle because they form a linear pair. So therefore, the other angle must be 126. because 126 plus 54 is 180. Now that I have this angle, I can look for x because that's my intercepted arc. So I'm going to substitute it into the formula. The measure of my angle is 126. That's going to be equal to 1/2 the intercepted arc, which is x. And now I'm going to solve for x. In order to solve for x, we're going to multiply by 2 on both sides, or divide by 1/2. So this will be equal to 2 times 126. And therefore, x is equal to 252. Next, I want you to pause your video and I want you to try number 8 from your worksheet, and I'll display the answers when you resume. Here we go. The measure of the angle that we're interested in is 90 degrees. To find the measure of the intercepted arc, you just plug in and solve for x. Next, I want you to pause your video again, and I want you to try this problem. When you resume, I will show you the answer. So, what you need to recognize is that this semicircle here is 180 degrees. Therefore, I can solve for x by substituting into my equation again. The vertex for the angle, whose measure is x, is on the circle. So x has to be equal to 1/2 the measure of the intercepted arc, which is 90 degrees. And I want you to notice that anytime I inscribe a triangle in a semicircle like this, my angle must be 90 degrees because it intercepts this 180 degree arc. Now, to find y, since I have a right triangle, or really any triangle, has to sum to 180, the measures of the angles have to sum to 180, and therefore y must be equal to 180 minus the 90 minus the 40, and y is 50. Now let's try some problems where the vertex of the angle is outside of the circle. And you can see for problem number 2, this is the case. So we're going to go back and we are going to look at our formula. The measure of the angle has to equal 1/2 the difference between the big arc and the small arc. So we're going to substitute in. The measure of my angle is x. I don't know what it is. It's going to equal 1/2 the larger arc, which is 142, minus the smaller arc, 52. And I'm going to move this over so I have a little bit more room to work. And then I'm just going to do some arithmetic. 142 minus 52 is 90, and therefore x must be equal to 45. So same kind of thing, you're going to plug in your formula and then you are going to just solve. And in this case it was nice and easy because it was just straight arithmetic. I didn't have to use any algebra at all. Now I want to try this one. This is a little bit different because you're still thinking, okay, vertex is outside of the circle. I need 1/2 the big arc minus the small arc. Well, the small arc is clearly 125. The question is, what is the large arc? And the large arc is right here. So as you can tell, this whole circle is 360 degrees. So my large arc must be 360 minus the smaller arc, which is 235. Again, that was 360 minus the 125. So now I know what the large arc is, and I'm ready to substitute in, and I'm going to move this over so I can see a little bit better. Nothing like changing what side I'm on. Substituting in. I don't know my angle, but I know the large arc is 235 and the small arc is 125. So now I'm just going to use some arithmetic and solve. That's 1/2, let's see, 1/2 110, which is 55. Now we're going to try some problems where the vertex is on the inside, not on the center. And problem number 3 is a problem of that type. So you'll notice I'm going to use the formula, the measure of the angle is equal to half the sum of the arcs. So let's move this over so I can use it a little bit better. And I'm just going to substitute in. Notice that the arcs I'm talking about are the ones opposite this angle right there. I have the 75 degree arc and the 25 degree arc. So now I'm just going to substitute in. I don't know the measure of my angle. I know it's equal to half the sum of the arcs. So arc 1 is 25, arc 2 is 75. So x must be equal to 1/2 of 100, and that is 50. Next, I want you to pause your video and I want you to try this one. And when you resume, you'll see the answer. You can see that I simply substituted into my formula for when the vertex of my angle is inside the circle, not on the center. And 77 was the angle measure. It's equal to 1/2 the sum of the arcs. Now, what's different about this problem is that I'm going to have to use some algebra to solve. And rather than distributing the 1/2, I multiplied both sides by 2 and solved for x. X is 132. That is the end of the video segment for this section. If you did not get any answers correct, please go back and check your work. We're going to spend some time in class doing some problems like this and giving you some practice. Have a great night.